Hey there, science fans! Welcome back to another exciting journey into the world of technology. Today, we're diving into the fascinating world of microprocessors, the tiny brains behind our phones, computers, and so much more. These little marvels are the unsung heroes of modern technology. Our story begins in 1971 with the groundbreaking Intel 4004. This was a pivotal moment in tech history. This little chip, roughly the size of a fingernail, was a game changer. It was a marvel of engineering and innovation. It was the first microprocessor, packing the power of a computer onto a single chip. Imagine fitting an entire computer's processing power into something so small. Before the 4004, computers were massive machines that filled entire rooms. They were expensive, cumbersome, and not accessible to the general public. The microprocessor revolutionized computing, making it possible to shrink these behemoths into smaller, more accessible devices. This innovation paved the way for the personal computers we use today. Think of it like this. The 4004 was like inventing the first bicycle wheel. A simple invention that paved the way for incredible advancements in transportation. Just as the wheel transformed travel, the microprocessor transformed computing, leading to the tech-savvy world we live in now. Over the years, microprocessors have been on an incredible shrinking spree. What once started as large, cumbersome boards have now evolved into tiny, powerful titans of technology. Remember the Intel 4004, the size of a fingernail? It was revolutionary for its time, but it was just the beginning of an era of rapid miniaturization. Today's microprocessors are thousands of times smaller, with transistors, the tiny switches that make up a microprocessor, now measured in nanometers. These transistors are the building blocks of modern computing, enabling faster and more efficient processing. A nanometer is 1/1000th of a meter. To grasp how small that is, consider this. It's a scale so minute that it defies ordinary human perception. To put that into perspective, a sheet of paper is about 100,000 nanometers thick. Imagine stacking 100,000 nanometers to equal the thickness of just one sheet of paper. That means we've gone from fingernail-sized chips to chips with components smaller than the wavelength of visible light. This leap in technology has transformed the way we live, work, and communicate. This incredible miniaturization is the result of advancements in manufacturing techniques. Precision engineering and innovative processes have paved the way for these tiny marvels. It's like taking a giant cookie and finding ways to cut it into smaller and smaller pieces without losing any of the chocolate chips. Each piece retains its functionality, but in a much more compact form, making our devices more powerful and efficient than ever before. As microprocessors have shrunk, their power has skyrocketed. This is due to the increasing number of transistors we can cram onto each chip. Remember Moore's law? It's the observation that the number of transistors on a chip doubles roughly every 2 years. More transistors mean more processing power. Think of it like this. Each transistor is like a worker in a factory. The more workers you have, the more products you can make. This exponential growth in transistor count has led to the incredible computing power we have today. Your smartphone has more processing power than the computers used by NASA to land astronauts on the moon. The miniaturization of microprocessors has transformed our world. Computers have gone from room-filling behemoths to sleek laptops, tablets, and smartphones that fit in our pockets. This incredible shrinking act has made technology more accessible and affordable. Remember when only big corporations and universities could afford computers? Now, billions of people around the world carry more computing power in their pockets than entire generations before them could have imagined. It's like the difference between having a giant Encyclopedia Britannica taking up an entire shelf and having access to all the world's information on a device you can hold in your hand. Section 5. Moore's Law predicting the future of tiny tech. Gordon Moore, one of the founders of Intel, made a prediction in 1965 that became known as Moore's Law. He observed that the number of transistors on a chip doubled roughly every 2 years. Amazingly, this prediction has held true for over 50 years, driving innovation in the semiconductor industry. It's like a self-fulfilling prophecy, pushing engineers to constantly find new ways to make things smaller and more powerful. While there are physical limits to how small we can make transistors, engineers and scientists are exploring new materials and manufacturing techniques to keep Moore's law going for as long as possible. Section 6. Milestones in miniaturization, moments that mattered. The journey of the microprocessor is paved with incredible milestones. We've seen the first single-chip CPU, the Intel 4004, evolve into today's multi-core processors that power our most advanced devices. Along the way, we've witnessed the rise of personal computers, the internet, and the mobile revolution, all made possible by the shrinking microprocessor. Each milestone has brought about profound changes in how we live, work, and interact with the world. Remember the excitement of getting your first computer, or the amazement of using the internet for the first time? These moments were made possible by the tireless work of engineers pushing the boundaries of what's possible with these tiny chips. Section 7. The microprocessor's impact. It's everywhere. Today, microprocessors are ubiquitous. They're not just in our computers and smartphones, they're in our cars, appliances, traffic lights, and even our coffee makers. These tiny chips have revolutionized countless industries. They've made our lives easier, more connected, and more entertaining. Imagine a world without microprocessors. No internet, no smartphones, no video games. The microprocessor's impact is undeniable. It has fundamentally changed the way we live, work, and interact with the world. Section 8. The future is nano. What's next for these tiny titans? As we approach the limits of Moore's law, researchers are exploring new frontiers in microprocessor design. Quantum computing, neuromorphic computing, and three-dimensional chips are just a few of the exciting areas of research. These innovations are not just theoretical, they are being actively developed and tested in cutting-edge laboratories around the world. These next-generation technologies promise even faster processing speeds, lower power consumption, and incredible new capabilities. Imagine a world where your devices are not only faster, but also smarter and more efficient. Imagine computers that can solve problems in seconds that would take today's computers years or even centuries. This leap in computational power could revolutionize fields like medicine, climate science, and artificial intelligence. The future of microprocessors is full of possibilities. From enabling more sophisticated AI to creating more immersive virtual realities, the potential applications are limitless. As we continue to push the boundaries of miniaturization and innovation, we're not just making things smaller, we are making them more powerful and versatile. We can expect these tiny titans to continue to transform our world in ways we can only imagine. From smart cities to personalized medicine, the impact will be profound and far-reaching. Stay curious, keep exploring, and who knows what amazing technological marvels the future holds. The journey of discovery is just beginning, and the possibilities are endless.